Previously in this class, we've talked about the rule of four, which is that any function that you look at can be considered through four different sort of methods. We can think of it as a table of values, a graph, an equation, and a written description. And more than just thinking about it as four separate things, we want to be able to think of it really as just four expressions of one thing. So we want to be able to go from a table of values to an equation and back. We want to be able to go from a table of values to a graph and back. We want to be able to go from a written description to a graph, and then also the other direction. And so we start to think of these things as being all related. Okay. Today, we're just going to focus on three. We're going to leave the written description out for now. We'll talk about that tomorrow. Previously, we were talking about the equation and the graph, being able to go from equation to graph and graph to equation. But now we're going to add in the table of values. So we're still going to go from equation to graph and graph to equation, but we're also going to go from table of values to equation and table of values to graph. All right, so let's start with the table of values. And I am going to give you a linear function. And it's important to distinguish that this is linear. It is not exponential. We previously studied exponential functions. But here's an example of a linear function. I want you to write this down. So let's say we're going to start at 2, 0, 2. And then we're going to have 5 and 8 and 11 and 14. And let's go back and let's say that -1 will be -1. Now, as we look at what is happening as I go from one number to the next, what pattern do you notice? If I were to ask you for the next term in the sequence, what would it be? Did you say 17? If you did, you're correct. And the way that you did that was you added 3. You said 14 plus 3. And you notice that, we have this repeated addition of adding 3 each time we go up, and we subtract 3 each time we go down. Okay, so we're going to take this table and now we're going to put it in our lattice of information. So let's say we had -1, 2, 5, 8, 11, 14. And we recognize we're not going to be able to graph those because when we look at our graph doesn't go up to 11. So now I'm going to plot these points. I have the point -1, -1, 0, 2, 1, 5. Oops. The scale on this one is different. Let me redo that. -1, -1, 0, 2, 1, 5, 2, 8, 2, 8. Okay. Now I recognize here that I'm not going to be able to do those other points, right? So there we go. And I notice, it's a line. It still lines up. But now the question is, what is the equation? Well, I can see clearly here that it crosses at over 0 up 2. So I know that my y-intercept is 2. Maybe it would help me to write it b equals 2. And then I have to figure out what m is. What is m? Well, from one point to the next, I go up 3, I rise 3, and I go to the right 1. I rise 3, and I go to the right 1. Rise 3, right 1. Rise 3, right 1. So it appears to me that my slope is 3 over 1, also known as 3. Where did that number 3, where did that come from? Well, let's write our equation and then we'll answer that question. Y equals mx plus b, or y equals 3x plus 2. Okay. Where do we see these numbers in our table? That's what we want to answer today. Where do we see b equals 2 in our table? And where does the number 3 come in to play in our table? I'm going to go back up here. So we're only focusing on this. Remember, m equals 3 and b equals 2. Where do we see those numbers appear in our table? Take a moment to look for them. Well, hey, I see b is 2 right there. The y-intercept is 2. When x is 0, y is 2. When x is 0, y is 2. And if we were to look at our graph here, here's our x-axis. When x is 0, we have the point 2 over 0 up 2. When x is 0, y is 2. Okay. All right. So that sort of reminds me a little bit of some of the stuff we did with exponential functions. Okay. And then what about m is 3? Where do we see 3 in our table? And we don't actually see it in our table, but we see, that's the number that I keep adding. Interesting. So our equation, y equals 3x plus 2, the 3, the repeated addition, gets shortcutted as multiplication. Interesting. So we're going to look to see if that occurs elsewhere in other problems.